Hi, today I'm talking about LeetCode problem 1405, longest happy string. So a happy string is a string that doesn't contain any sequence of AAA, BBB, or CCC. And what you're trying to do with this problem is find the longest happy string given a fixed number of A's to include in your string, of B's to include in your string, and C's. So, if C was 100 and A and B are 1, you're eventually going to run out of A's and B's, and you would have to start packing in more C's, and you would get to AAA, BB, whatever. You would get to 3 C's in a row, and that would no longer be a happy string. So if you had or in the example I was saying, if you have 100 C's and 1 A and 1 B, you could do CC A, CC B, C, C. You can't add any more A's, you can't add any more B's, you can't add a C, so this would be your longest happy string. And what they're asking you to do is just return the longest happy string given an integer A, an integer B, an integer C. And yeah, you're guaranteed that these are all going to be positive numbers. 100 is the maximum value, so it's not going to be too large. I think that's that's pretty much everything we need to know about it. Oh, and you can return any happy string, any longest happy string, if there are multiple equivalent ones. So, CCB, CCA, CC is an equivalent string, and you could return either of those. So how I solved this problem is I thought first, just how would I do this if I was asked to do this? Like, I'm not a computer, I'm just a human. How would I use my human brain to solve this? And so I have this example, I'm given 7 A's, 2 B's, and a C. Well, what I would do is I'd just take the most frequent letter and I would start using them until I would violate the rule of, oh, I can't add another A, because then I'd hit 3 in a row that were the same. Okay, so then I'd use one of my B's, I'd use my next most frequent letter, and then I'd go back to using up my A's. 1, 2, 3, 4, so this would be down to 3. My B is down to 1. I'd use another B. B is at 0. Use another couple A's, AA, and then I'd use a C, and then I'd use my final A. So that seems pretty straightforward to me, and I don't see any way that could go wrong. Like, the only time my string can be unhappy is if I use 3 things in a row, 3 letters in a row, and I'm prohibiting myself from doing that just by this operation. So let's go ahead and implement that solution. Now I've done that, is the first thing I'm going to do is I'm just going to create a dictionary for A, B, and C. And the dictionary is because I want 2 values, kind of named values, a char, the character that represents the A, the B, and the C, and a count, how many of them I have left. So you might be thinking, why not use a tuple or a name tuple for this? And my reasoning was that I want it to be mutable. I actually want to change the count with every iteration of a loop that I'll show you in a second. So because I want it to be mutable, I am using a dictionary to represent these kind of objects, A, B, and C. And I could have used an object for them, and that might be better if this was, not just a trivial LeetCode problem, but I didn't do that. So the next thing I'm going to do in line 7 here is I'm just going to sort them with the key being their count. So put them in order, basically, of how many I have left. I've actually been thinking about this in between the time of when I solved this problem and now. I don't know if I even need to put them in order, because so long as I follow the same rule. So like if I tried using my C's first, C, C, B, C, okay, then I'm out, then I use, B again. I can use B again. Now I use an A, then I use my final B, and then I would use 2 A's. Like this seems to produce also a longest string. So I don't think, strictly speaking, I need to sort them, but I did. And then I'm just going to filter out any that are less than 0, that have a count less than 0. So there's a case where, I'm given a 0, that's allowed. And I don't want to use a letter that has a count of 0 in my letters list. Result is just a string that I'm going to build up the result on. And then add back is a list. Intermittently, I'm going to be popping the top of my letters list off to use it, to start adding it onto result. And when I'm done doing that, I want to push it back on the letters list. And that may make more sense in a minute when I show you how I'm using it. So I'm going to say while the length of my letters list is greater than 0, what I'm going to do, this is an outdated comment. I originally thought I'd do 2 at a time. I thought I'd solve the problem by going, why not CCB, CCB? Why not add 2 at a time? But I encountered the reason why you wouldn't add 2 at a time. There's a possible case where the most frequent letter kind of changes places. So it's hard to say. I guess it's hard to exactly to put into words, but like right as B overtakes A for the most frequent letter, then picking the most frequent letter would have kind of a special case if you were adding 2 at a time, where my implementation of it would sometimes add 3 in a row. So this comment is out of date, but I think it might be even faster to add 2 at a time, but it would be more complicated to figure out when you can add 2 at a time and when you can't. So anyway, I'm popping the top letter off, and the top letter is going to be the one that has the most count left, the most number of times I can use it left. So as I pop it off, I'm just going to push it onto my add back queue or list. So, okay, I popped it off, so I want to be sure I put it back on. This check right here is just to say that we can't use the most recently used letter, or more specifically, we can't use a letter if the last 2 of our result string would be equal to 2 iterations of that letter. So if this is saying the last 2 characters in result string, and this part is saying 2 times the character represented by top. So if 2 of top's characters is equal to the last 2 of our result string, or and our result has more than 1 character in it already, then we just want to continue. And what continue will do is just bring us back to the top of the loop without executing anything else. And so you may know that, or you may notice that when we go back to the top of the list and pop off the next letter, the previous top is already off of our letters list, and it's in the add back list. So if we hit this condition on line 19 and we continue, we'll pop off the second most frequent letter, and we'll add it into our add back list. So the next thing we do is we just add a top character to the end of our result list, of our result string, and then we're going to decrement the count of our top character. We've used 1, so we will use 1 less top character going forward. And then the final thing we're going to do is just add back all of the items in our add back list. So this says while there's more than 1 item in the add back list, what we're going to do is pop the top off that add back list, and if it has a count that's greater than 0, we're going to append it back onto the end of our letters list. So this will add back however many we have in our add back list if they have a count greater than 0, and they may not, because we're decrementing their count when we add 1 to the list. And if they do have a count that's less than 0, then they're just going to be popped off our add back list, and they're going to be lost or gone forever. We aren't going to do anything more with them. And then I'm just going ahead and sorting my letters list again so that we're always in the case that the top of the list is the most frequent letter. So I guess next I'll just talk about the test cases I used for this. So the test case they gave me in the example, 117. Other test cases would be their other examples. You might as well use those. Other test cases I did would be the large number constraint. So what if all the values are at 100? I did 90 here for some reason. Another test case would be what if 2 of the values are 0? Another test case I think would be useful would be what if the values are 1, or what if it's 1, 1, 1. I actually, I originally solved this on a separate computer, so I don't have all the test cases I originally used here. I solved this on a separate computer, and I'm just recording it on my laptop. But yeah, those are the test cases I used, plus a few more. And so running it, I think it's going to get something like, well, in this case, it got faster than 95% of other Python solutions, which is pretty good, but I think that has to do with the variance in LeetCode. Other times I've run it, it's been a little bit slower than that. It's been maybe 70% as I've been kind of working on making it faster. So I think what would make it faster is, can we add more than one letter at a time? Another way to make it faster is this notation here is actually creating a new string when we say result start with -2 and to the end. So I think it would be even faster. Oh, and this creates a new string when we multiply by 2. So I think it would be even faster just to say if the top character was equal to the -1 result and the -2 result. And then, yeah, I think it would be even faster still to actually use a data structure. It's called a pairing heap, which would maintain the balance of the most frequent character without having to pop and push onto 2 separate lists. So I feel like using something like that might be faster still. Let me just check and see if I do need to keep my list sorted. I haven't really thought that through. It doesn't seem to me like I do. Okay, it seems like I can create a problem for myself if I don't do that. I'm not going to debug that while recording, but apparently there's some edge case that I'm not thinking of intuitively where I do need to keep it sorted. Anyway, yeah, that'll do it for me. So if you enjoyed this video, let me know by clicking the like button. If you want to see more LeetCode problems solved, I'm going to aim to do 1 a day, and I'll just record myself walking through it and explaining how I solved it and how I tested it and that kind of thing. Yeah, leave a comment to let me know you're watching, and thanks for your time.